This brief video presents a brief overview of the Quarry Vision Systems optimization systems, showing how it links sales, operations, and production using real-time scale data where it's available and applying field measurement evaluation of performance, yield, and capacity capabilities when the scale systems are not yet installed. It begins with a menu that allows you to recall previously created models. The scenario list shows the names of all previously saved files, and you can bring them up one at a time or two at a time for comparison of alternatives to do the what-if analysis that are so critical sometimes to be able to get a true visualization of what the effect of various limits and capabilities have on your process and on your profitability. The system comes up with a header bar showing a menu of various options, starting at the left, excluding the date, which I'll explain later. We have the optimization objective alternatives: maximum margin, sell tons revenue, selling only, and production only. So we can actually do variations on what it is we're trying to accomplish and see how that alternatives affect the profitability results, and particularly how they drive the operating schedule. You can see the other menu items, and we'll go over those as we move forward here. The planning process in an aggregates operation, out of necessity, starts with the evaluation of sales. Jeez. The planning process in an aggregates operation starts with the generation of a sales forecast, and the connection of the sales forecast is what you're looking at here to the optimization model. The intention is to make the interface between what your current sales format for entry might be invisible, so salespeople can continue to use the terminology that they are familiar with and create the forecast for monthly sales tons and selling price in a format that is consistent with what everybody's used to. And this makes it possible then for easily updating the forecast and connecting it to the model without any manual entry. Option exists to save or not save. In this case, we'll not save it. Carry on with evaluation of the interface to the optimization from the sales forecast. You'll see I've used a previous example model, and I've excluded in the gray here. You can see I can turn these on and off as far as the optimization is concerned, and it affects the tons that are in the forecast. But I've excluded those in the gray because they are produced by, at this particular location, a ancillary plant. And by the way, these are current products, but the tonnages are not proprietary. These are all made up, but reflect a reasonable approximation to what this plant could or should be expected to produce. You'll see that each product has its item number. The item number is associated with a blend menu that defines the selling product in terms of the stockpiled product, so that if you do have a fractionated plant, it can convert the sales forecast from what the salespeople need to see to a stockpiled product forecast, which you see down here, indicating what the production plan has to be focused on. And you can see as I turn products on and off over here, they link over here to show you what those translate to. And I've got one that's turned on. Damn. You'll see on the menu bar on the sales sheet, the option exists to change the sales forecast. So you can see I've got 2 sales forecasts listed. You can see there could be as many as 30 on this sheet, and it's a matter of how many I include in the development. I can hit a refresh to make sure there's nothing that's been added since then, and I can change the sales forecast from the 2014 forecast, which is there, to the 2016 forecast simply by
updating sales source file. Please wait.
Oops, a little loud. It takes just a bit to transform the links from the original file to the new file. But it's a lot faster than manual entry in any event.
Update completed. The selected sales forecast file is now linked to the optimization application.
And the computer tells you what it needs to tell you at certain points in the program. Moving on from the sales blending and conversion, the next element is defining capabilities of your process. The system is set up initially to manage 4 stages of processing. The limit to that is only what is practical for and necessary for each plant. There can be as many stages as necessary. I break it down into a primary segment, segment 1, segment 2, and segment 3. In this case, segment 1 is where the main screen plant is that produces the products. You can see there are a list of modes here, and again, these are not proprietary results. These are practical results for this type of a plant. The products are listed here, the stockpile products. In this case, the secondary, or segment 2, is the reprocessing segment that I've excluded from this example. Segment 3 is associated with segment 2 in this case because it is the stage that recovers inventory that has been rehandled for reprocessing. So you'll see that the percentage yields are expressed as a negative at the recrush stage. Each segment has a capability for its key elements of constraint to be included: start month, end month, and the month thing is an option that most people work toward. But in terms of the actual in connection with the full analytics measurement side, this would all be represented in weeks, so you would have week schedules instead of month schedules. Better for this presentation to show it just as the month because it's quicker. The ton per hour operated and the percentage of time that is scheduled that would actually be run are entered here manually. However, with the full performance system with the measurement tools, it would be statistically represented here based on a year-to-date number or whatever period of time that was chosen by the operator to use for purposes of establishing realistic current capabilities. Even with that filled in, though, the operator or the manager or whoever can still override by entering in the manual side, and then the manual side will then take charge. These are constraints up here: the min week, max week, start month, end month. Minimum weekdays tells the optimization system whether there is a expectation that there will always be something going during that month 2 to month 12 basis. The maximum days obviously can go as much as 7. The minimum hours and the maximum hours again have a direct relationship to the number of people working and the number of shifts scheduled. And again, the minimum number is not required. If the minimum number is off, then the computer will adjust the number of hours based on the maximum limit, and then drive toward the maximum tons, maximum revenue, or maximum margin. The ton per scheduled hour is a reflection of variable cost. Fully variable, controllable cost. No amortization, no fixed cost, no overhead, no management. Just what can be controlled. Scheduled hours calculates from down here, and this comes from the optimization. The average hours that are here reflect on all modes, unless a mode ton per hour or mode percent runtime are entered, then those control. And now we become even more capable of constraining or defining the limits and capabilities of the process. The end result of the optimization in terms of management interface and for planning purposes is the operating schedule. And the optimization system is set up in its stages. And here I've shown the 2 stages that I'm not using, but you can see that hours are placed by the optimization in the modes that are best to drive to match the sales and inventory constraints that are applied elsewhere. The same constraints that were applied on the other sheet can be applied here. It can be modified appropriately. The results are here and summarized, similar, same results as from the other page. One thing that's important is that this also allows you to bias your optimization by including or excluding certain modes. And you can put them back on if you want to, so you can turn them on and turn them off. So the optimization will only look at the ones that are highlighted. So if you want to drive it towards something in a focused fashion, or you want to test a mode, for example, you could turn them all off and run a single mode and forecast what's going to happen, then go back to your performance side and validate that what you said was going to be the yield is actually going to be the yield. Production results are displayed in a number of different manners. This is a basic summary of the production, and you'll see that the production constraints are shown here on the far right. If I put the chart on, you can see the graphic representation of what's been shown to be produced. You'll see over here I made a provision for inventory adjustments for waste loss factors, and you'll note that there's numbers here, but you'll see that I've not turned them on. I can turn them on and turn them off. You can see the effect of various loss factors, and those could be real loss factors in process, or there could be inventory adjustment factors that need to occur for purposes of correlating reported production with measured inventory. Variances in inventory throughout every plant in the country result in periodic adjustments that can result from anywhere from a couple of $100,000 to several $1 million, and inevitably a learning process with a measured system can be applied that makes it zero in to match the variables associated with measured inventory. You'll see this doesn't show a production in August, September, and October. That's because of constraints that were applied during a previous example that I was running for myself. Additionally, the inventory presents similarly. Eventually. It includes the graphic representation showing, in this case, the starting inventory versus the new ending inventory. And that is a mathematical calculation directly off the starting inventory plus or minus production. And the constraints are shown here also. And the inventory change calculations are obviously an indication of the cumulative effect of the change in value related to production and sales.